Hi there. Welcome everyone to RxJS Live Asia. I hope everyone's been having an amazing time so far learning all things about RxJS from the people who write it and the people out in the community that have been doing some really, really amazing things with it. I am the last speaker here of the day, so I just wanted to give you all a little bit of a perspective of where ArcGIS came from, as well as some ideas for the future. It's still hard for me to believe that it's 11 years ago that RxJS really first came to be, and even reactive extensions well before that, maybe 14 years ago, and yet here we are at a conference dedicated to RxJS. And it's really amazing to me how it's evolved over time from something that was kind of written by hand and then later constructed with tools like Grunt and Gulp and so forth to what it is today is really mind-blowing and awesome. So today we're just going to talk about how we go above and beyond what we already know with the observables. So who am I? Who the heck am I? Well, I'm unoriginally on the internet. I am Matt Podwysocki, aka Lambda Calrissian. And I'm also on GitHub as well. And occasionally, just occasionally, I'm on Twitch when I do various live streaming and code and so forth. And yes, I still do wear the hats, although it's kind of hard to wear it and wear these headphones at the same time. But I hope coming soon to a theater or venue near you that I can wear this again. But yeah, do check out that out, and I hope at some point in the near future that I'll get back to streaming again. So I work at this place where we've created some really breakthrough technologies such as Clippy and Comic Sans. It's a small company out of the Seattle area called Microsoft. And in that, I've been there for a good number of years now, where I first started working on the reactive extensions back in 2009, 2010 timeframe. To where we are today, where I'm working on other projects. So currently, I'm working on a team called the Azure Notification Hubs. So if you think about push and push collections, you're exactly right. I'm kind of in my alley here, where we're talking about push notifications at at scale, pushing millions upon millions of push notifications to your phones, computers, watches, etc., on a daily basis. So like I said, is I'm really kind of into this whole push notification, push and reactive and so forth kind of model. But I first want to put it out to everyone that async coordination really is kind of awful. The way that we've had to do a lot of this in the past has been far from optimal, where we've had to adopt so many different languages and tools just to try and make our lives a little bit easier. But ultimately, it has its own problems in that a lot of the things that we try are non-compositional or hard to reason about, or you have one library that differs from another. And so all of these sorts of things make it really hard to compose things together in a single coherent story. And wouldn't it be nice if we had something that did allow for something to combine it all together? Because let's face it, that it really is awful. So what we've always been talking about with callback hell is still very true to this day, although it's gotten a lot less worse with time as Node has adopted promises and many other libraries have adopted promises. But it's still very much with us in a lot of the APIs that we use, that callbacks are fundamentally one of the core building blocks. And that's great and everything, in that it allows us to build on top of them with promises, observables, and so forth. But by and large, they're very hard to reason about, because it's not like I can easily compose these things. These callbacks are, or continuation passing style, is where kind of everything happens at the end. So it keeps on building over and over and over and over. And the error handling mechanisms aren't automatic, so they had to become more idiomatic, such as with the callbacks returning error as the first argument, and the results, if anything, as the second argument. But ultimately, it's really, really hard to reason about, which is why you had libraries such as async and so forth come out with ways of dealing with that. But even still, the idea of events still to this day are non-compositional, just because of their nature, in that it's basically the subject-observer pattern, the subject being the a DOM element, for example. Then we have the observers, which are basically the event listeners that we add onto our particular pieces, such as mouse up, mouse down, and mouse move, etc. So, for example, if we wanted to draw something, we would have to say mouse down, control whether mouse down and mouse up is happening, and if so, draw or do something, otherwise reset the state, kind of thing. So it's really non-compositional in the fact that you have to have these three different listeners doing three different things, and not as part of one chain or anything like that. And yes, we do have a lot of things like promises, but for the longest time, we had promises that weren't quite complete. They had their own set of problems, as it were, because it had a number of issues. The first one was that you couldn't really cancel a promise once it went out the door. It was in a microtask, and it would finish when it finished, and it goes to the then or to the catch, depending on whether it succeeded or failed. But there was nothing fundamental in the promise itself to say, like, promise abort or anything like that. But we did have libraries such as Bluebird and others that physically added the abort syntax to the promise, but that ultimately was not accepted as a thing necessarily for promises. So instead, what we got was this. So a lot of people instead stuck with the old XHR or XML HTTP request, because you had the abort semantics. But just as well, we didn't have any way to deterministically say something was finally going to happen either. You just had a cavalcade or a cascade of thens and catches, and so forth. But there was really nothing to say do something at the end. It did finally make its way through, but there is a kind of a standing joke here of how many engineers does it really take to cancel a promise? And by the number of comments there, you can kind of do the math yourself of 240. So sure, certainly it became a thing eventually, which is great, because now what we have is we have the ability to use the .then syntax and so forth to get our response and turn it into JSON and then log it out, but also to catch, for example, anything being aborted. So we can say that we can create something through the abort controller, and the abort controller was first standardized through the DOM, and has now been making its way through to Node as well, as a standard way of doing cancellation. And now when we go to async await, we have this very deterministic way of like, for example, starting a spinner, doing a fetch, getting the response back. But if it's an abort, show don't do anything. But if it's something other than an abort error, show the error message, and then finally stop spinning. That in itself is really, really powerful in that we now have this mechanism, which is actually external to promises that people can start to use in a number of other things. But the fundamental question is can we do better? And if you're like me, I'm in that situation where I was dealing with callbacks and promises and everything else, and we all these disjointed APIs, and asking myself, really, could we do better? And the answer is of course we can do a lot better things if we think about the past, go back to the past, and think about some of those things that we've learned in the past. So let's go back to the days pre Windows XP, and let's think big. I don't know how many people actually remember those days pre Windows XP, but we'll just go with it and dream big about what we can do to make asynchronous programming less awful. So in 1973, we had the actor model. And the actor model was inspired more by physics and so forth, and languages such as Lisp and Smalltalk and Simula, where you could have a number of these independent agents or actors, and the only way that they communicated with each other is through is directly from one actor to the other. So we can have ping and we can have pong, for example, where they can send messages back and forth. And this is just using a third-party library in JavaScript, but it's a fairly decent way of doing concurrent programming. If you think about if you think about things like Erlang is really good at doing everything's an actor and everything's separated, isolated memory, and let it crash, etc. In JavaScript, maybe it's interesting, but it is definitely something to think about, where it's really got these core pieces where they can send a number of messages to another, and then designate the behavior of what it does when it receives a message is really kind of interesting. So it's how it's isolated itself from another, and how it isolates state and so forth. Another way we could think about it is this notion of CSP, or communicating sequential processes. Now, this differs from the way that we were talking about actors previously, is that instead we have these independent channels, for example, channel A and channel B here, that are independent of one another. And the way that those two processes, process A and process B, can communicate is through channels. So I can say, put something on a channel B, and someone else can put something on channel A, and so forth. And this was created back in 1978 for a way of talking about concurrent systems back in 1978 by Tony Hoare. And it's been kind of the default way of thinking about asynchronicity in such languages as Go and, of course, Clojure, but hasn't really caught on as well in the JavaScript world. It's just like the actor model. It's fairly, you have to wire up a lot of things yourself, and there's no for example, common way of handling errors and so on. So you've got kind of these channels, but up to you in terms of how you want to do any error handling or any number of those things. So really, are there any other options? So going to 1994, the Gang of Four book came out, and it really describes a good number of patterns that we use in a lot of today's languages, such as the iterator pattern, such as iterating over an array. And then they also had such things as the subject observer pattern, which was also kind of cool, in that you had this idea that you have this subject and it could push values to you over time. And whereas the iterator, you pull values from it. So there was this duality of push to pull that, although they never formalized that directly in the book itself, when creating the reactive extensions, we actually did kind of say, well, really, it's kind of a flip of one to the other, where one is a distinct pull and one is a distinct push. Now, I always like to be a little controversial and talk a little bit about functional reactive animation and FRP, in that when I describe reactive extensions and so forth, I don't ever say it's FRP. And the reason is because that was really defined as something else. And it was defined back in '97 with functional reactive animation, or FRAN. And it's differentiated really between Rx, especially when there was a distinction of behaviors or events. So you had up top, you have this notion of a behavior which always has a value regardless over time, versus below, where you had discrete events happening, such as mouse clicks. Whereas a behavior could be, for example, a mouse movement. You could always have a client X and a client Y. So that really kind of did influence, of course, some of our lines of thinking, that you could use maps, filters, flat maps, etc., over these kinds of things. And yes, we could always talk about monads, and what talk isn't complete without them. But I'll leave it up to the late great Joe Armstrong to really tell you what a monad is. It's a thingy, is the best way that I'm going to describe it. But really, Rx then came out of a design where we could, where you see the logo and you're like, wait a second, that's the RxJS logo, or Reactive Extensions logo. Well, kind of. It came from the Live Labs Volta project, in which the idea was that you could write an application in C# and you can compile it down to JavaScript if you want to, or a desktop app and so forth, and have the ability to tier split and run part of it on the server and part of it on the client. But the real challenge is how do you marshal over an event, which is this thingy, over to the client and back and forth. And that's what really led to the design of the observable, just as well as this whole notion of language integrated query, or LINQ, in which we are talking about how we can use our mouse as a database. So your mouse is something that you can query. You can query its mouse coordinates, its mouse clicks, every kind of thing that you can get out of it is something that's queryable. So a mouse should be no different than a database that you can query it. The only difference was over time, and that really led to this whole reactive extensions that you see today, where you can literally write it in the language of your choice. And there are so many other languages, and depending on their popularity and so forth, that they continue to this day. So when we talk about where the observable belongs, we're really talking about asynchronous over time, and multiple values, just as we can do with iterable, where we can do maps and filters. With arrays, we can do the same with observables. The duality being the push versus pull, just as the object of assigning and the promise of the value being pushed back to you. But during a push-pull model, there are a number of problems that can ultimately happen. And quite honestly, things can overload. there are many problems with that observable design in that everything is largely based upon a pure push model. The pure push model meaning that if the producer is sending so many things that the consumer cannot keep up with, then the consumer ultimately dies or does something here, or ultimately shoves chocolate in their mouth. You couldn't imagine reading a 2 gig file or things like that directly and having the system throwing all those bytes at you as fast as it can, regardless of how fast you can process it. So that's the real issue. And how do you solve that? Well, observables obviously can get you part of the way there, in that we have a number of things where we can kind of crimp the hose or kink the hose so that we aren't always going to send you or blast all of the data out at you at one time. It can be lossless in such a way that we can buffer or window it so that we're talking about giving you glimpses into your data over time. Or we can say there's lossy pieces where we don't care if we drop a byte, or we don't care if we drop a mouse event. We don't care if we drop the keyboard event, just because we are more interested in the aggregate and the whole. So it's really kind of a something that you can decide to do. But ultimately, it could also lead you down to the path where you have the observable hammer and everything looks like a nail, where although the observables are really good at what they do, maybe it wasn't the best choice for you at that particular point. For example, I use observables in a lot of the code that I write, but at the same point, there are places that I would never put it. And it really gives you a pull versus push kind of conflict that we have here versus pull push or push pull. Now, what I mean by pull push and push pull is they're kind of hybrid in the way that I can tell the system, hey, I want another value, and it will push it to me, versus the producer will push a value at me, and at my leisure I can pull it then into the system. So it's really kind of a hybrid of how to get there. And so when we talk about other data patterns, that's exactly what we're going to be talking about, is pull push and push pull. So with the recent versions of JavaScript, we've gotten this notion of an AsyncIterable. And all you really have to do to implement this is implement the symbol.asyncIterator symbol method, where you can yield pretty much anything, whether it's a string or a promise, and then you can for a weight of going over all of the values in there, which is kind of cool in the fact that now you've got this way of building up an asynchronous stream using yields and so forth. That's really kind of neat. And just as well, so instead of having a lot of the stream callbacks and event emitters that that Node has, you can use that as a general of reading through a file stream. So you can do try, catch, and so forth over these streams. So that brings us to the first thing, which is the IxJS AsyncIterable. So IX is kind of the opposite of Rx. So IX has the pull collections and the pull push collections, such as the AsyncIterable. So if you know Rx, chances are you'll know IX pretty well, because it follows the same kinds of principles. It's got the same style of operators. It's got the same style of imports and everything else, and largely with the same core team members as well, as trying to explore other avenues of querying collections over time with this pull push model. So we can do maps and we can do filters and so forth, and use the try, for, await, and try. And just as well, the built-in abort controller does not actually support abort syntax or the abort controller. So what we do with IX is we actually have a way to go in there and add in the abort controller that we've seen before and inject a signal in, so we can decide if at any point we need to stop hit the brakes, as it were, on the particular thing. So it's really kind of cool that we can plummet all the way through. But to do that, I have to kind of go against the way that it's currently doing, because currently the symbol async iterator doesn't take any arguments. But if I really want this to go through, I have to kind of plummet myself to do so. And then when we can implement an operator ourselves, such as map, we can implement it so we can for, await, and wrap this abort controller for us, passing in the signal, and then we can perform the map and yield the results through it. So that's really kind of neat, in that we can now pull over these things. And as you can see through transform data and filter data, is the fact that they all get the abort signal passed into them, so that at any point, if you need to send it to another operator or whatever, that it can propagate the cancellation or abort semantics for you. And just as well, we have this notion of an async observable. So as we said, there are some issues with the observable itself. Why could we not just asyncify everything on the observable itself? And we do have an ongoing pull request on this to add in the ability to do maps and filters and so forth, and have concrete ways of creating an observable asynchronously, but also to tear down asynchronously. And that's something that currently Rx does. Observables, as of was written, originally written, did not support. But not only that, but it didn't support the throughput of the abort signal as well, all the way through. So for this, it's more of a working to create this kind of fusion where we can deal with, say, network traffic in more advanced scenarios, where we're dealing with network traffic or other things where we're dealing with asynchronous closure and or an opening of pieces, as well as awaiting data as well. So why do we have yet another library that we would even consider more than observables? And for the AsyncIterable, for example, you put the consumer in charge of the data flow. First and foremost. So it's not like the observable, where it's continuously throwing pieces of data at you. You actually have control. And not only that, but it has then deep integration with the node and DOM streams themselves. So DOM streams being things that are built into the browser, and then node streams or Deno streams built into those systems. And we can enable async projections all the way through with map, filter, flat map, and so forth, that each of those can be asynchronous projections as well. And with the async observable, it's kind of the same thing of putting the producer in charge, where the consumer can pull as needed, but it also allows for those async projections, as well as the async creation and deterministic teardown, as well as adding in abort controller APIs as well. So really, when we're talking about this entire thing, we're talking about observable, AsyncIterable, and AsyncObservable. But where will we go next? What is largely going to happen next? And there's a real interesting thing to that is that we can now start to think about this as being part of the browser or part of the runtime itself. So an iterator helpers is a proposal currently in stage 2 that was looking to add in things like map, filter, and so forth to directly to the array methods or iterables, and using IX as obviously as one of the inspirations for that. And I would certainly love to never have to write another library like this and have it directly built into the runtime itself. So following along this is pretty exciting. But now that I realize we are out of time, I want you to leave you with this, is that although we know the observable is amazing and awesome, there's a lot more that we can do when we start to think about other problems that we can solve with the same kind of techniques that we've learned using RxJS, but also using, for example, IxJS when you need it. So with that, I want to thank you very much for your time. This has been an amazing event in that it really gets to bring the RxJS community together and discuss ideas. It's really, really amazing, and it blows my mind every single time that I see anyone doing something with RxJS that I would never have conceived of years ago. So thank you very much, and bye.